Yeah, thanks a lot. I could not have introduced myself better than you did. Scarce, expensive, and volatile energy, indispensable value, revenue, and growth to our investors. That is what I want to talk about. My name is Gero Ferges. I'm the CEO of AHT Syngas Technology, and I'm happy to present our company and our products today to you. I would like to talk a bit about the history, where we are coming from. Then I continue with our business models and products, continuing with HT in numbers, how we developed, where we are heading to, about our growth strategy and outlook. And lastly, I talk about the management and our share structure, just to round up the presentation. Yeah, to the history a bit. The first electricity and mechanical energy was not produced with natural gas or diesel. It was produced with syngas. The first engine developed from Nicholas August Otto used syngas already to operate this engine. And if you exit the train station in Cologne, that's near where I'm living, you see one of the first engines and get an impression on how long and how proven this technology already is. So I took over this business from my father. We are listed at the Frankfurt Stock Exchange, to make it short, and now we are continuing our growth path, and we are continuing to build up our company, and we do it with our different products and with our different value chains. So what do? We convert fixed biomass into biomass and residues and waste into a syngas. And how we do it? We have a double fire gasification process. I will explain it later. So at high temperatures, we convert our input material into a synthetic gas. A synthetic gas consists out of carbon monoxide, hydrogen, and methane. So it's a burnable gas, and nowadays you call it green molecules as well. That is what we are producing with our high temperature process. And we use wood, biomass, waste RFD, so waste fuel, biochar or sewage sludge, and many other components to convert it at the high temperature and up into our products, which can be synthetic gas, which can be used in a boiler. We can, as a byproduct, produce biochar. We are, as I said, we are converting the molecules of the input material into the gaseous form. Because we do it with a high temperature, we have a very clean and pure gas what we are producing. And this clean and pure gas can then be used, for example, in the CHP, for the production of electricity. We have a byproduct which is heat and cold in this case. And what is becoming more and more interesting are the emission certificates, the greenhouse certificates, which offers additional revenue as well. So how do we generate our income? Mainly at the moment, we are generating our income by equipment sale. So we have a standardized product line, which I describe later, which is sold to our customers and partners, and they operate it on their own. We are about to entering the contracting market, so we do not only want to sell our equipment, but we want to operate the units for more steady and more plannable income. That is the next big step we want to do with the company. So not just selling the equipment, but to operate it for 10, 20 years, depending on the feed-in tariff or on the offtake of the energy. And when we are operating our own units, we are able to trade, on the one hand, the gas, on the other hand, the greenhouse gas certificates as well, when we are, for example, producing biochar, or if we are producing renewable energy. So before I go into detail, I want to explain our technology a bit more simplified. And I have three, I think, important topics where our technology fits in, and how to describe it. So when you imagine a fire and the flames you see which are burning, that is the gas which is burning. And what we do, this is to describe our technology. What we do not support enough oxygen that this gas will burn, but we collect it, we suck it from the process, then we cool it down and treat it in order to have these molecules still unoxidized, unburned for further use. What we additionally do and what is important for us, if you compare our technology, we are not a biogas system. You know, these systems with the green or with this bubble on top of the big vessels. We operate at high temperature and we focus, and that's important for us, that we use non-edible feedstock. So we use all the residues, and I use the example of a sweet corn of a maize plant. So the seeds shall be eaten, and the corn shall be eaten, and the remaining the stock and the leaves. This is an input fuel we like to use in our systems to convert it into a synthetic gas. So that's very important for us, that we don't use food, or that we don't use sources which are in competition with food. The other thing which is important nowadays, so we will have more volatile energy from wind, from solar, and our biomass power plants are able to balancing these powers. So we can produce power when there's no wind, when there's no sun. We can ramp up our energy, and if there is sun and if there's wind, we can lower our output. So that is a big value, I think, as well, that we can produce the demand, that we can produce according to the demand, and that we produce the energy as well there where it's needed. So we prefer to place a system there where the energy really is needed, and do not need to be transported for long distances. This is the toolbox of equipment, what we are offering. So we have standardized our modules, and the modules start with the gasification process. I will explain later, but the core of all what we are doing is our twin fire gasification process. And then we start to purify in different stages. Either we filter the gas or we wash it and really remove impurities like sulfur, like chloride. This is especially important if you are using waste and waste residues, that we wash the gas before it's further used. Because we do this, and we do this with water. We have a water treatment unit to be able to recycle the water. And later on, then we can use the gas in, for example, the CHP to produce electricity and heat. We can already use the gas here when it's hot for industrial applications. I will explain this later as well. If you have a high temperature process in the industry, we can produce and provide a substitute for natural gas, greenhouse gas free or greenhouse gas negative gas for these industrial processes. All this equipment up front is to use different type of input fuel. So starting from the worst case, if you have sewage sludge, we have a drying and treatment unit which sterilize and improves the dewatering of this material. If we have powder material, we just briquette it and prepare it for our gasification process. And so that is what we do upfront. So this whole chain shows the components what we are offering, which are all standardized for our customers or for our own units. And this standardization is important that we can deliver for a good price and in a reasonable time this equipment for our own projects and for our customers. Okay, coming to the core of our technology, as I said, the twin fire gasifier, that is the core of everything what we are doing. And it's called twin fire because it has two zones we are using. We have the so-called downdraft gasification at the top of the process and the updraft gasification from the bottom. So we work top down and bottom up, and that's quite a motto in our company as well, that we always approach from different sides. So here the advantage is that when we put in fresh input material, we go through a drying zone, a pyrolysis zone, and this is when you still can have dirty gases, and this is what many competitors do have. They have still a quite dirty gas. So this is the reason why we put this gas through our hot zone, the oxidation zone, and destroy all impurities and all organic hazardous matter to convert these long chain carbohydrate chains into the molecules carbon monoxide, hydrogen, and methane. And this is what we are doing in the upper part. In the lower part, we do a updraft process. That is when you have imagine again the fire, the flames, that's the upper process. And at the bottom, you still have the coal left. And this is how you can compare it with a barbecue. You have the coal, which is still glowing. And so we can now regulate, do we want to extract the coal, which is becoming more and more actually a business. This coal is called a biochar, and this can generate greenhouse gas certificates. And it is a soil improver, and it can be used in the industry. So there's a big market for this biochar. But normally we come from the energy side, so this biochar still has a lot of energy value, and therefore we make the updraft process to convert all the coal into the syngas. But again, we are flexible, and that's the benefit of our process. We are flexible in the input fuel, as well as we are flexible in how we on our output stream. So we can either produce a bit more syngas or we produce the biochar. This is depending on the application and depending on the need of our customer, and that is where we are flexible. But to summarize again, this high temperature process operates at above 1000 degree, and this 1000 degree destroys all hazardous impurities, all organic hazardous impurities. If you are using waste or if you're using material with heavy metals, for example, this is extracted with the ash, and we can then treat the ash. If it is biological input material, it is a fertilizer, or even if you operate it in a way with the biochar, then we can produce up to 20% with the process of biochar as well. So this is, I make the link now to the market. We are unique in a medium size products. So there is some competition in the smaller size. There's some competition in the bigger size, but this is really the big competition, like the Siemens. In the smaller size, it's more the farmer's application, and we are the medium size with our plant and with our company addressing medium-sized companies and energy users as well. And in this market, there's a prediction of a growing bioenergy market and biomass market. On the one hand, it is still, although it is not a big topic at the moment, but it's still a growing and a predicted growing market. And together with this, the hydrogen and the molecules from biogenic input material is expected to grow very fast and very high. So our product to convert hydrogen out of biomass, we see a big future in this product, and I describe it a bit later. But all these markets where we are working in are growing markets and are expected to grow further. So our target markets and where we address this or how we address this market is different. There are the highly regulated market with high prices. For example, Japan, and Japan has a feed-in tariff. So when we produce our electricity there, we get a lot of money paid for the electricity. So this can support expensive equipment as well. If we are more in a market, in a more rural market or in a not so far developed market, there's a driving force is the existing energy price. And if it is decentralized and maybe there's even no grid connection, then we can produce very competitive energy in these markets. And this is the other side where we can offer. In general, in the industry, high temperature gas or high temperature applications, this is in the medium-sized energy with a high energy demand, and this is where we can place our systems directly next to the customers and operate these units. Regarding the safety and security and environment regulations, we will meet all criteria. We have done this several times and in many markets. So this is something where we have no problems because of this technology producing at high temperature and destroying all the impurities. Our USPs summarized here from the technology. We have an integrated technology platform with the standardized modules, starting from drying, briquetting, carbonizing, and the gas production. So as I said with the toolbox before, we put the different equipment together according to the demands which is at our customer. We have industrial and proven processes we can offer. We are able to use multiple feedstock, so we are able to use residues and waste. And we have core products which can be adapted according to the demands. Again, this is a biochar. This is when we produce hydrogen, we produce carbon dioxide as well, for example. So this is that we can operate our systems very flexible. We are in growing markets, as I mentioned before, either in the bioenergy market, but as well in the circular economy, renewable molecules. These are all the markets we can serve. We have standardized and with this scalable plants. So we have standardized all the modules until the last screw, and we are working with OEM manufacturers. So we can scale the company and the products quite fast because our main focus is on the engineering and how to operate, how to program the software. That is all done in the last years, and this can be used to scale it now. So these are the main USPs to mention. I don't want to mention them all now here in this presentation. Coming more to the systems, to some examples, what we are doing, that you get a better imagination of how our systems look like. Here in the background, you see a production company which are producing parts for the furniture industry, and so they have to paint all the parts they are producing. And although they already have renewable energy from solar and wind, they did not have a solution for the high temperature for the painting processes. So we offered them our system, and we installed our system to give them a replacement for their natural gas consumption. And here you see these are very standard container boxes. They are using their own pallets from or packing material. The local waste company collects these pallets, shred it, and deliver it back to the system. Then this shredded material is transported to our Syngas system. Here it is converted into a gas, and in this house it's filtered, and then this gas is just produced or delivered via this tube to the oven. In this case, there are three burners which serve these paint, high temperature paint drying process. So we produce the gas according to this paint facility. So if the paint shop needs more energy for the in-burning of the color, we produce more energy. If they need less, then we reduce our output. And so we can really operate the system according to the demand. And as you see, and that's why I like this picture so much, here you see a clear interface and clean interface to our customer. And in this case, the company is operating the system on their own. But in other cases, we can just supply our syngas via this tube and transport the syngas to the customer with a clear defined interface. This is, we call it a hot gas module, and for the commercial figures, this customer saves 600,000 euro in natural gas every year. Don't need to buy the natural gas at the gas company, can produce it from their own waste material. So they save on the disposal of the packing material, and they save in the purchasing of the natural gas. And they have a natural gas, carbon dioxide free energy production, so they have no greenhouse gas emissions, which is important for their global customers as well, that they can prove the production is really greenhouse gas free, and this ensured them already further big contracts with their customers, because they were the only company which could prove that they are really greenhouse gas free production facility. So they save 600,000 in the natural gas. The investment in such a unit is about 1.6 million euro. So a very fast ROI in developed markets. And this is where we see a big potential for the future. And this is what we want. This product is what we want to roll out to our customer, and specifically in Europe and Germany. The other main product what we are offering is a biomass power plant. Here's an example of a 2 megawatt unit in Japan. So as I said, Japan has very high feed-in tariffs, and such a unit will produce about 4 million revenue in electricity per year. Because of this high feed-in tariffs, with an investment in our equipment of about 8 million euro. So that is why I want to go into the contracting business, into the own operation of our units, because you see, one time business to sell the equipment is a good business, but if over 20 years this system generates a free cash flow of 60 million euro, This is much more interesting than just selling the units. However, we will not start in a market like Japan that is too far away. This is what we would like to do in Europe and in front of our door before we go later into the further away countries. This is the outlook, what we have achieved in the past and as well where we are heading to. So we want to supply our own energy from our own facilities. We have started to producing certified biochar as well. So that is a byproduct, but as I said, becoming more and more interesting to our customers. And yeah, in the future, we have a patent and we have a approved patent for hydrogen from biomass. So I'm running out of time. I only will mention this short that the production of biomass, of production of hydrogen for biomass, is another product which is based on our high temperature process again, and focusing in this case on the production of hydrogen and carbon dioxide. So we shift the process in the direction that the main focus is on the hydrogen production. We have applied for a patent, and this patent is granted. The political circumstances in Europe are a bit not stable, let's say, or it's not very clear where the direction is going to. So, but however, this is a product we have prepared in a big due diligence for the future. And once it's more clear where the direction, the political direction in the different markets it's heading to, we are ready to use this as well. A quick overview of our project. So we are focusing in the near future on projects in Austria. Here we have a big project pipeline, and one project is very far developed with a partner from us to supplying hot gas for industrial applications. And another big market for us is Poland, where we are preparing projects. Yeah, quick overview about the projects. Okay, you're coming in. This is the forecast.
I'm coming in because there's 1 minute left. That's most interesting. Finish on that, and then after that, I will have to go slightly to the next presentation.
All right. Now, this is outlook, and I think we can stop here as well with all the products we presented. That is the outlook where the company is going to based on the GBC research. And yeah, thank you for giving us the opportunity to present. And
all right. Well, thank you very much for the great presentation. We had a lot of questions planned here, Mr. Ferges, but you answered almost all of them during your presentation. It was very clear what you guys are doing, the business model. So thank you for that. We'll be very much looking into following the story. I think the development is going to be extremely interesting, both with what's happening in the EU, with your plan, with your expansions, and so on. And so thank you very much for joining. And we'll be again happy to follow your story in the next few months.
Thank you.